Okay, we will start today with chapter 9, document 6, integrative properties of nerve centers. We have explained in this lesson some paragraphs. We will make a quick review about them. First, what do you have to know before we start? You have to know the neuron, the concept of neuron, and its parts. I will make a very quick review. You have to know that the neuron is able to transmit nervous messages, action potentials, and the action potentials are transmitted not in the same speed in all of the fibers. Then you have to know that we are able to make stimulation of the neuron. And when you stimulate a neuron, you will obtain an action potential. You will obtain a nerve message, yes, in the fiber that will be transmitted toward the nerve ending. Also, you have to know everything about the synaptic transmission with all the steps: arrival of nerve impulse, opening of voltage-dependent channels, also the entry of Ca2+ ions to make fusion of the synaptic vesicles with the presynaptic that will make exocytosis of neurotransmitters, and then binding of the neurotransmitters on the postsynaptic channels that are chemical dependent channels. In this case, in this figure, they are Na+ chemical dependent channels. These channels, when they open under the action of the binding of neurotransmitters, they make entry of Na+ ions to the postsynaptic cell that will make a postsynaptic potential inside of it, which will be able to make a postsynaptic nerve message. After that, there is a degradation of neurotransmitters by specific enzymes and reuptake of the products of this degradation. These are all the steps of the synaptic transmission. Now, and we have taken also something about the types of the synapses, and we asked them, ourselves that what if many synapses are together making messages? For this girl, I have to remember you about the possibility for her to be under the action of many stimulations, light stimulation and alone not able to give her a reaction, to force her to make a reaction, and also the sound sensation alone, it didn't force her to make a reaction. But when both of them together, the hand that passes in front of her and the sound is emitted also behind her, we obtain a reaction of eye blinking. Now, it seems like that there is a center that is receiving messages and that is giving messages. And when there is only one message afferent to this center, which is represented here by a neuron, but the center actually contains many neurons, a big number of neurons, but we have to simplify the thing simplify the ideas in order to understand them. Only one message will not give an efferent message, a message that is going out of the center, and the other message that is afferent also will not give an efferent message. But when both messages are together transmitted to this center will give an efferent message that will lead to eye blinking for this girl. Now, we have to know what are the types of the synapses, and I'm also reviewing now the types of the synapses. If you want to make a review, a very deep review of these concepts, you have to refer to the video 5.1 on the same channel. Now, we said that we have two types of synapses. The first is an excitatory synapse, and that leads to what? What do we call this? This is EPSP, or excitatory postsynaptic potential, and the other one is an IPSP, or inhibitory postsynaptic potential. In the case of excitatory postsynaptic potential, the channels are Na plus channels, chemical dependent channels, and the entry of Na plus will make the inside of the neuron less negative, leading to the increase of the membrane potential. And in the case of the inhibitory synapse, the channels are K plus or Cl minus. If they are K plus, there is exit of K plus. If they are Cl minus channels, there is entry of Cl minus. In both cases, we have more negative, electronegativity inside the membrane, and which will lead to the decrease of the potential of the membrane potential to less than the resting potential. These are the ideas that we have taken, and we will now start by new ideas. Let's see. Now I want your help. There is, in this new concept, an attempt to explain the reaction of that girl that was receiving two messages at the same time. Because of that, I titled this part "Reception of Many Nerve Messages from Different Neurons." Let's see. If, in this case, the neuron is receiving two messages. Let's see. This is the first message. Do you see it?
Yes.
What did it give?
An ISIP.
An EPSP. Okay.
Yes.
This is the second message. Look at the oscilloscope. We observe at the oscilloscope a red,
smaller EPSP.
and it is a little bit smaller, a little bit
ESCP.
a little bit smaller. Okay. Now, what if now you have to observe here the two messages will come together. What do you observe on the oscilloscope?
A larger EPSP, an action potential.
And it reaches the threshold leading to an action potential.
Yes.
Okay. So when the two messages arrive at the same time, they have the possibility to be what?
Action potential.
To be or to make an action potential. If you have, or if you want to know this, to name this process, what can you name it? What did they do? What do the two okay. It is a summation. This is a summation of the two EPSP. I can't make summation for two action potentials. I'm making a summation of the first EPSP obtained from the first fiber and the second EPSP obtained from the second fiber. Their summation leads to a higher to an EPSP of higher amplitude, and this will lead to an action potential since it reaches the threshold. Okay?
Yes. Yes.
This is the first type of summation that can be done by the neuron when it receives two messages from two different sources. Okay? Now, let's see. We call this, can you read with me?
Spatial summation.
Spatial summation, yes. This is a spatial summation. Why?
Okay.
If you think about the name, why do we call it spatial summation?
Mm-hmm.
Can you think about the word spatial from where do we take it from what term? I will tell you. This is taken from the term space.
Yes.
Why from the term space? Because in the space we have many directions, many possibilities to receive information from many directions.
Yes.
As in this case, the neuron had received information from many directions, and that's why it makes summation in a spatial manner. That's why we call this a spatial summation. We have to understand the names in order to remember them for a longer time.
Yes.
And in order to not switch between the terms. This is the spatial summation. Now I have to ask you a question. Does the spatial summation always lead to the creation of a nerve message in the postsynaptic neuron? What do you think?
No.
No.
لازم تكون فوق الثريشولد.
Yes.
Oh, yes. A very important thing that is the spatial summation should give me an EPSP higher than the threshold. Okay?
Yes.
Let's see, for example, in this case. I will show you now this simulation. How many messages does the fiber receive?
Two.
Two messages. Okay.
Yes.
It received two messages, but if you see them, the first is from the excitatory synapse, and the other is from where?
Inhibitory.
From the inhibitory. Okay, thank you. Now, the EPSP is shown here in red color, and the other is an IPSP shown in blue color.
Yeah.
Mm-hmm.
What will the sum of them give?
The yellow one in the middle.
Yes, which is lower than
The threshold.
the threshold and lower at the same time than the EPSP itself.
Mm-hmm.
Since this summation is a summation of an amplitude of positive value and another which is a hyperpolarization of negative value, correct?
Yes.
Their summation will subtract the values from each other to give us this small EPSP that is surely lower than the threshold and that will not make an action potential. Okay?
Yes.
This is the case of when we make two messages coming from two different neurons, one inhibitory and one excitatory. And also it is the case of when two excitatory postsynaptic potentials do not give me an EPSP higher than the threshold. It will not give an okay. Thank you. This is the case of another type of summation. This summation, is it as, can we call it spatial summation?
No.
No.
Think about the sources. Are the messages from the same source or from different sources?
From the same source.
I will repeat. Let's see. we will observe here and here. Okay. Did you observe them? How many sources are there?
2.
2 sources. I posed it. There are 2 sources. So if there are 2 sources, what can you know?
Spatial.
Yes, you can. Spatial summation. It is of the same type as the first one. It is a spatial summation.
Yes.
Okay. Now, the spatial summation, if we have to make a quick, brief conclusion, a spatial summation is a summation of many action potential from
The
how
same
many
source.
sources?
Different sources, sorry.
Different sources. Whatever these sources are, if they are 2 excitatory or 2 inhibitory, perhaps, or 1 excitatory and 1 inhibitory. Clear? This
Yes.
is the spatial summation. Now we will pass to another idea. No. To another idea, this is
Temporal.
no. I will start now here. This is another simulation. Now observe clearly, observe very carefully from where would I receive messages. You observe them. What do you notice?
From the same source.
These are the messages. How many messages are there? 1 or many?
Many.
Many action potentials are transmitted to the postsynaptic cell. Do you think that they will make an action potential?
No.
Can they make summation, the one on the other in successive manner? Let's see. Observed on the oscilloscope, how did they make? Did they make summation or not, or no?
Yes. Yes.
Yes, they do make summation. I will repeat. I will repeat the simulation in order to carefully observe what is receiving, what is the neuron receiving, and what does it give me on the oscilloscope. Okay. I see here that I have this first EPSP, the second EPSP, and the third EPSP, that they are summed up together, and a little bit by a little bit, they reached the threshold and they gave me an action potential, correct?
Okay.
Correct.
Can we call this a spatial summation also?
No.
No, since what?
From the same source.
They are obtained from the same source, not from different sources. Exact? Yes, very good. And if they are from the same source and they make summation, they will give me an action potential if they reach the threshold. Okay? Now, if they are from the same inhibitory source, they will give me many hyperpolarization to below the resting potential. And in that case, if they are many inhibitory, they will make also a temporal summation, this kind of summation, a temporal summation, but in negative value. This is what we call what? Temporal summation. Okay? Okay. What does this term temporal refer to? It refers to time, not to space.
Okay.
Because the summation now is done within the time.
Yes, yes.
the one after the other, it is done within the time. Because of that, we call it temporal summation. Okay. What happened in the reality? I will show you this small simulation. In the reality, always the nerve center in the most cases receives many messages, not only two, many messages from a big number of sources, and from each source it will receive many action potentials, not only one.
Yes.
In that case, if I have many sources, so the summation is what?
Okay, the summation is leading to action potential.
If we obtain many from many sources, what is this summation called?
Spatial.
Okay, thank you, spatial. And in the same time, if I'm receiving many action potentials from the same source, what is this summation called?
Temporal.
Temporal. Because of that, in the reality, the summation is what I gave you,
Spatial temporal.
Spatial temporal summation. This is the summation that is done in the most cases in reality in our nerve centers.
Both of them.
Okay. I have one more idea. Let's go back to that girl.
Yes.
The girl that we saw, and she has two stimulations, one light by the hand and the other by a sound. What is the type of summation done by her in order to make eye blinking?
Spatial temporal.
Thank you, thank you. It is a spatial temporal, since each of the messages gives in her body a frequency of action potentials, and the two frequencies make summation together in order to give her the reaction of eye blinking that is obtained and that we saw it in the video at the beginning of this presentation. Okay, this is a spatial temporal summation that allows us to make some reactions. Okay. This is our new idea that we have explained now, and that I will give her a name or a term that refers to all of what we have explained. This is the term of neuronal integration. This is the process that is done by our neurons. We call it the neuronal integration. The integration of the nerve messages correspond to making spatial summation and temporal summation of many messages in order to give a unique spatial temporal message obtained from the neuron, and that will make us able to react properly to the stimulations that we are receiving. This is the neuronal integration of the nerve message. I have to say thank you for all of you. Thank you to help me to record this lesson, and inshallah we will be able to record more lessons in the future about the new terms that we have to learn together this year. Thank you very much, guys.
Welcome.
Welcome.